Good morning, sir. I am Rutuba Firza from Tribly Department and my roll number is 244 G1A0244. My topic name is de Broglie's hypothesis. Introduction to de Broglie's hypothesis. De Broglie's hypothesis proposed that the particles such as electrons exhibit wavelength behavior. These ideas revolutionized the field of quantum mechanism and changed the understanding of matter. It suggested that all matter is associated wavelengths known as matter waves. Historical context of de Broglie's principle was started in earliest 20th century was time of rapid advertisements in physics. Classical physics struggled to explain phenomena at microscopic scales, especially electron behavior. De Broglie work emerged in response to the limitation of classical theories like Newton's machines. Louis de Broglie, the man behind the hypothesis, is Louis de Broglie. He is a French physician born in 1892, known for his groundbreaking ideas. He presented his hypothesis on matter waves in 1924, earning him the Nobel Prize in Physics in 1929. His work laid the groundwork for wave particles duality, a central concept in quantum physics. Wave particle duality describes how particle can exhibit both wave-like and particle-like properties. De Broglie's hypothesis exhibits this concept to all matters, not just photons. This duality is fundamental to understanding phenomena such as electron diffraction and interference. The de Broglie's wavelength. The de Broglie's wavelength is defined by the equation lambda is equals to h by p, where h is Planck's constant. Here p represents the momentum of linking wave particles to physical characteristics. This equation allows for all calculations of wavelength associated with any moving particle. De Broglie's equation derivation and its significance. The de Broglie's hypothesis states all moving particles associated with both the wave properties such as particle properties. According to de Broglie's hypothesis or equation, a matter particle is motion in also associated with wave. It is represented by lambda is equals to h by mv is equals to h by p. Impact of electrons. De Broglie's hypothesis impacted electrons behave like waves when compared with an atom. This wave-like behavior explains the quantized electrons levels observing in atomic structures. It suggests that electrons do have fixed orbitals but rather exist in probabilistic wave functions. Experimental evidence. The most famous experimental evidence supported by de Broglie's hypothesis is electron diffraction. When electrons are passed through a crystal, they create an interference pattern. Conformed wave behavior, such as experiment valid the concept of wave-particle duality proposed by the de Broglie. The Schrodinger's equation. De Broglie's idea directly influenced the development of the Schrodinger's equation in quantum physics. The equation describes how the quantum states of a physical statement changes over time. It incorporates de Broglie's wave concept, providing a mathematical framework for wave functions. Applications in quantum mechanism. The applications of quantum mechanism are de Broglie's hypothesis has significant impact in fields like quantum mechanism and solid-state functions or physical functions. It aids in the understanding of phenomena such as quantum tunneling and electron behavior in atoms. Applications including electron microscopes, which exploits wave properties of electrons to achieve high resolutions. De Broglie's impact on physics. De Broglie's hypothesis that has influenced theories behind quantum mechanism, including quantum field theory. It has prompted future research in the nature of particles and their structures and infrastructures at a fundamental level. The concept of matter wave has opened new advancements for exploring the universal underlying particles and principles. Criticism and limitations. Despite its significance, de Broglie's hypothesis faced uh, from some physics despite the significance, de Broglie faced skepticism from some physicians initially. Critical argument that not particles exhibit wave-like behavior or clearly as electrons do. Later development in quantum mechanism helped address these concepts, solidifying its acceptance. De Broglie's hypothesis. We have seen that a radiation not have dual behavior or wave-like and particle-like structures. In 1992, de Broglie suggested that the same in the is true for matter, specifying he proposed that frequency and wavelength can be associated with an electron, energy, and movement. Here, lambda is a de Broglie's wavelength. We can recall photons. We can represent photons as E is equals to PC is equals to HC by lambda. De Broglie's relation holds for photons is legacy of de Broglie's work. Louis de Broglie's contributes continue to be a cornerstone of modern physics and quantum theory. His work has inspired countless physicists to explore the duality of light and matter features. The legacy of his hypothesis endured in outgoing research in quantum mechanism and related fields. Conclusion for de Broglie's hypothesis. De Broglie's hypothesis transformed our understanding of fundamental nature of matter. It it empathizes the wave-like properties of particles, illustrated the complexity of quantum world. Today, de Broglie's ideas remains integrated to the study of physics influencing future discoveries. F- Feel free to modify any context or any values needed for preparation. Thank you, sir. Thank you for giving this opportunity.